what you have to be able to do is recall the certain values from your unit circle. So just as a reminder, 0 degrees is equivalent to 0 radians. Remember that quadrant 1 trick that I showed you from the unit circle. So remember, if you look at quadrant 1 from the unit circle, remember the ordered pair on your x-axis is 1, 0. You've got your 3 special angles, and remember that quadrant 1 trick to help you remember quadrant 1, because if you can remember quadrant 1, you should hopefully, with some transformations, be able to come up with the other values. Remember, I told you at these 3 angles, make a bunch of fractions with a denominator of 2. Then starting with your y-coordinate, down here at the angle closest to the x-axis, start numbering. With a 1, go up 2, 3. Then go back down. 1, 2, 3. Square root all of the numerators. Well, square root of 1 is just 1. Here's square root 2. Here's square root 3. Square root 1 is just 1. Square root 2, square root 3. And then remember, the ordered pair up here on the positive y-axis is 0, 1. Remind me again, x goes with what trig function? X is your what? Cosine, y is your sine. Remember, this is your 30 degrees, or in radians, pi over 6. In the middle is your pi over 4, or 45 degrees. And then you have your 60 degrees, or your pi over 3. Because you do need to remember all these values for the remaining part of the unit. So remember, in radians, remember 0 degrees or 0 radians, you have the ordered pair 1, 0. So the cosine is 1, sine is 0. Because remember, sine is your y-coordinate, cosine is your x-coordinate. Remember, tangent is your y over x. And then the tangent is 0 is 0. Remember, at 30 degrees in radians, you have pi over 6. At pi over 6, if you look at your ordered pair, the y-coordinate is 1/2. The x-coordinate is square root of 3 over 2. Remember that tangent trick I showed you? The tangent, if you look at it in radians, how many 3's make up a 6? How many 3's are there in a 6? 2. So the tangent of any pi over 6 is going to have the 2 3's, the square root of 3 over 3. 45 degrees in radians, remember, is pi over 4. Remember, the x and y are the same as square root of 2 over 2, square root of 2 over 2. And remember, the tangent at 45 degrees is 1. At 60 degrees, again, in radians, that's your pi over 3. At pi over 3, the y-coordinate is square root 3 over 2. The x-coordinate, which is your cosine, is 1/2. And remember your tangent trick. Look at your radians, pi over 3. How many 3's are in a 3? 1. So your tangent of the pi over 3 is just going to have 1 3, which is square root 3. So what we're going to be focusing on using these sum and difference formulas is we're going to find exact values of other angles that are not a member of the 30, 60, 90 family. But what we're going to do is you first have to determine 2 unit circle values whose sum or difference is the given angle. So using a combination of my 45, 60, and 90, adding them together or subtracting them together, I'm going to come up with a combination of my unit circle angles to match the given angle that I want to find the exact value for. For the given problem, there may be multiple. In other words, there may be more than one correct combination of angles that you could come up with. And you'll still get the same answer in the end. Use the appropriate sum or difference formula. And then you're going to have to evaluate your common trig values from the unit circle. And then you simplify your answer with no radicals in the denominator. So this is what we're going to be focusing on today. So here's an example. Find the exact value of the cosine of 75 degrees. Remember, if it says exact, That means it's a no calculator question. Means you'll know decimals, you'll have it in radical form or fraction form. Well, 75 degrees is not an angle from the unit circle, is it? It's not one of those exact ones. So now what you want to think of, you've got 30, 45, you've got 60. So using your 30, 60, 45 degrees, you can go out of quadrant 1, you can go to 120, you can go and use your 135, you can do your 180, you can use your, which one am I missing, 150. So any combination, and I could go all the way around the circle. I need to find two magical numbers that I add together to give me 75 degrees, or if I subtract to give me 75 degrees. So can anybody pick two angles that add together to give you 75 degrees? Yeah, Anna? 30 and 45. So does everybody agree with me that 30 degrees plus 45 degrees is equal to 75 degrees?
I believe that sounds about right.
Could there be another combination of angles that I could subtract, perhaps? Yes. Doesn't mean it does. So you may pick a pair of angles that's different from mine, but you should still come up with the same answer in the end. So then what I'm going to do is I'm going to rewrite 75 degrees as the cosine of 30 degrees plus 45 degrees. So now this is where my blue sheet's going to come in. I'm adding two angles together, and I want to find the cosine. This is my alpha, this is my beta. So am I going to look under the sum formulas, or am I going to look under the difference formulas? Sum. So on my blue sheet, I'm going to look at my cosine sum formula. So remember, on my blue sheet, the cosine of alpha plus beta is equal to cosine alpha, cosine beta, minus sine alpha, sine beta. And again, that's just recopying from my blue sheet. So now what I want to do is I want to substitute. So I've labeled that 30 degrees is my alpha. I've labeled that 45 degrees is my beta. Some of you may have written down on your paper that it was 45 plus 30. But you agree with me that addition is commutative. So it doesn't matter if you had 45 plus 30 or I have 30 plus 45, it's fine because we know addition is commutative. So now what I want to do in my cosine sum formula, anywhere I see an alpha, I'm going to plug in 30 degrees. Anywhere I see a beta, I'm going to plug in 45 degrees. So I'm going to rewrite my cosine sum formula as the cosine of 30 degrees, cosine of 45 degrees, minus the sine of 30 degrees, sine of 45 degrees. Now you should have an expression with all the angles that are from the unit circle. So any questions on how I did the substitution? So now this is where you have to remember your unit circle. What is the cosine of 30 degrees? The cosine of 30 degrees from your unit circle is the square root 3 over 2. Times, what is the cosine of 45 degrees? Square root 2 over 2. Minus sine of 30 degrees. So again, the y-coordinate at 30 degrees is going to be 1/2. Times the sine of 45 degrees, which is what? Square root 2 over 2. Okay? So all I've done is I've now gone to that's why I said you've got to know that unit circle, because from this day forward now, that's kind of our first step. We're now doing the applications of the unit circle. We've had all this time to practice, practice, practice. Now, if you want to simplify, follow your order of operations. You have multiplication and subtraction. So by PEMDAS, what do you have to do first with these fractions? You're going to do what? Multiply. So remember how you multiply fractions together. You multiply numerators and denominators together. What is square root 3 times square root 2? Square root of 6. Over the denominator, 2 times 2 is 4. Minus 1 times square root 2 is square root 2 all over 4. Luckily, you already have a common denominator, so I can condense this into the square root of 6 minus square root of 2 all over 4. and I can't simplify my radicals, make sure you check to see if you can simplify radicals, or if you need to rationalize those denominators. So any questions on how we use the sum and difference formulas from the unit circle? All right, let's take a look at, yeah, Joanna.
You can't subtract the radicals?
No, remember, in order to subtract radicals, whatever's under the radicand has to be the same number.
Oh.
You can multiply unlike radicals, but you cannot add and subtract them. Okay? All right. So now let's take a look at an angle measurement in radians. So now we know in radians you've got your pi over 6, you've got your pi over 4, you've got your pi over 3, you've got your pi over 2s. Notice this denominator is not pi, it's not a 3, it's not a 6, it's not a 2. So what you need to do is you need to look at all of your special angles from the unit circle with a denominator of 12, because I want to find what the sine of 17 pi over 12 is going to be. So what would pi over 6 look like with a denominator of 12? That would be what? How can I rewrite pi over 6 with that common denominator? Yep, 2 pi over 12. So in order to find the correct combination of angles to add or subtract, you need to look at these angles with common denominators. So you all agree with me that pi over 6 is equivalent to 2 pi over 12 from the unit circle. I'm just picking angles because, again, you've got to find a pair of angles. Guys, shh. You've got to find a pair of angles from the unit circle that I'm going to add or subtract to give me 17 pi over 12. So I need to look at these various angles, just like I picked the 30 and the 45 in the last example, but now they're in fraction form of the radians. So I need to look, because this denominator is a 12, in order to find the correct pair of angles, I've got to look at each angle with a denominator of 12. So another angle from the unit circle is a pi over 4. So with a denominator of 12, what's another way to look at pi over 4 with a denominator of 12? That's equivalent to what? 3 pi over 12. And then I've got pi over 3 with a denominator of 12. What's that going to look like? 4 pi over 12. I have pi over 2, and I could keep going all the way around the unit circle. Pi over 12 with the denominator of 12 would be 6 pi over 12, wouldn't it? So now remember, I need to find a pair of angles that add or subtract to give me 17 pi over 12. I can go into quadrant 2. 2 pi over 3 with a denominator of 12 would look like what? 8 pi over 12. I could go into 5 pi over 6. Yep.
Can you add more than 2 together, or just only 2?
No, it has to be 2. Mm-hmm. I also can consider pi, which is 12 pi over 12. So now remember, I'm trying to get to 17 pi over 12. Can anybody think of a pair of angles? Now I haven't listed all of them. I could also consider 3 pi over 4. So now can anybody find a pair of angles that I could add and subtract together to give me 17 pi over 12?
Pi over 4 and 2 pi over 3.
So pi over 4 and
3 pi over 4.
3 pi over 4.
And 2 pi over 3.
But wait a minute, 3 pi over 12, that's going to give me, that doesn't give me 12. I need to get to 17 pi over 12.
2 pi over 3 and 3 pi over 4.
Oh, okay. Yeah, that works. So does everybody agree with me that 8 pi over 12 plus 9 pi over 12 equals 17 pi over 12? So everybody agrees with me that 8 pi over 12 plus 9 pi over 12 equals 17 pi over 12. So in radians, like I said, what you need to do, if they're asking you to find the exact value of an angle from the unit circle, you've got to think about all those different angles from the unit circle with that same denominator. So again, when I simplify, I know that 8 pi over 12, remember, is actually 2 pi over 3. 9 pi over 12, when I simplify, is 3 pi over 4. So that equals my 17 pi over 12. So now I want to find the sign. I'm going to rewrite my 17 pi over 12 as 2 pi over 3 plus 3 pi over 4. So which formula am I going to look at on my formula sheet? Am I going to be looking at my sum formula or my difference? Sum. So again, this is my alpha, this is my beta. So from my blue sheet, the sine sum formula, and I'm just recopying this directly from my blue sheet, the sine alpha, cosine beta, plus cosine alpha, sine beta. Like I said, you don't have to memorize these formulas. You just have to make sure you know how to use them. So now what I want to do is I'm going to substitute. I'm going to take out my alpha, replace it with a 2 pi over 3. I'm going to replace my beta with a 3 pi over 4. So I'll have the sine of 2 pi over 3 times the cosine of 3 pi over 4. Plus cosine of 2 pi over 3 times the sine of 3 pi over 4. This is where, ladies and gentlemen, you need to be really, really careful of your negative signs. These negative signs can eat you alive. All students take calculus. Know your location. Know whether or not the value is going to be positive or negative. So because these angles are no longer just in quadrant 1. So be careful. In quadrant 2, because that's where 2 pi over 3 and 3 pi over 4 is located. Remember, all students take calculus. What two trig functions are positive in quadrant 2? What does that S stand for? Remember, that S stands for what? Sine and its cosecant. So remember, in quadrant 2, only sine and cosecant are positive. The other 4 are negative. So be careful when you're doing your unit circle substitutions here. So what is the sine of 2 pi over 3? I know it's going to be positive, but at 2 pi over 3, the sine value is going to be what? Which one is it going to be? It can't be negative because sine's positive. But what's the value going to be? Is it 1/2, square root 3 over 2? Is it 1? What is it from the unit circle? Square root 3 over 2. Times. Now it's the cosine. In quadrant 2, cosine is what? Positive or negative? Negative. And what's the cosine of 3 pi over 4? It's going to be what? Negative what? Square root 2 over 2. Plus. Cosine of 2 pi over 3. Again, 2 pi over 3 is in quadrant 2. Cosine is negative. So it's going to be negative what? What is the cosine of 2 pi over 3? Negative 1/2. Sine of 3 pi over 4 is going to be positive square root of 2 over 2. Guys, I can't emphasize this enough. If you don't know the unit circle, you're not going to get any of these problems right. You've got to know the unit circle. All right? So now, just like in the last problem, multiply before you add. So when I multiply square root of 3 over 2 times negative square root 2 over 2, that's going to give me a negative square root 6 over 4. Negative 1 times negative square root 2 is a negative square root 2 over 4. So you write plus a negative, or you can just write a minus. That's up to you. They're equivalent. The denominators are already the same, so it's going to be negative square root 6 minus square root 2 all over 4. So like I said, guys, these formulas expand the number of angles you can find the exact value for, but again, using your foundation of that unit circle. Yes, Emmy?
Could you determine sine pi over 12 into radians and
You could, but it's going to take you a lot longer if you have to keep on doing that over and over. And plus, you may make a mistake in the conversion. So now find the exact value of 13 pi over 12. I've listed quite a few angles. Can you find a combination of angles that are added together? I've already got denominators of 12. That would give me 13 pi over 12.
4 pi over 12 plus 9 pi over 12.
Yep, 4 pi over 12 plus 9 pi over 12. So everybody agree with me that 4 pi over 12 plus 9 pi over 12 equals 13 pi over 12. Again, 4 pi over 12, remember, is equivalent to pi over 3. 9 pi over 12 is the same as 3 pi over 4.
Are these always going to be improper fractions?
Most of the time, yeah, in radians you're not going to see mixed numbers. You'll see them as improper fractions. Okay?
So the numerator's never going to be bigger than...
Unless you're in quadrant, unless you have an angle smaller than pi.
So, okay, so it can be, the numerator can be less than... the
Yeah.
denominator.
If the angle, this just happens to be an angle greater than pi, so that's why you see the numerator greater than the denominator. But no, it could happen. Yes, Jay?
I have a question. So I was just doing one of the practice problems, and so like when you're doing difference formula and the sine or cosine is negative, and you also have the negative for the subtraction, would you make it a positive? Or what would you
Yep.
do?
Yeah. A negative, remember, minus a negative becomes a positive. So now the tangent, guys, again, looking on your blue sheet, you're adding the two problems together. So remember, from your blue sheet, your tangent of alpha plus beta, tangent's always going to be your trickier ones because you're going to end up with complex fractions. So tangent of alpha plus beta is your tangent alpha plus tangent beta from your blue sheet over 1 minus tangent of alpha, tangent of beta. Again, alpha is your pi over 3. 3 pi over 4 is your beta. So plug it into my formula. So I have the tangent of pi over 3 plus the tangent of 3 pi over 4 over 1 minus tangent of pi over 3 times the tangent of 3 pi over 4. So all I've done is I've substituted into my tangent sum formula. Like I said, you don't have to memorize the formulas. So any questions on how I plugged pi over 3 in for alpha or 3 pi over 4 in for beta? So now going back to the unit circle, what is the tangent of pi over 3? The tangent of pi over 3 is what? Square root 3. Plus, be careful, 3 pi over 4 is in quadrant 2. Is tangent positive or negative in quadrant 2? Negative. And what's the tangent of 3 pi over 4 going to be? It's going to be a negative 1. Over 1 minus. We've already talked about the tangent of pi over 3 to be square root 3 times negative 1. So any questions on how I substitute the unit circle? What I'm going to do is I'm just going to move down here so I don't get squished here. So I have, for number 3, square root 3. Remember, plus a negative 1 is equivalent to a minus 1. What happens when I have this double negative right here, negative square root 3 times negative 1? That's going to become into a what? Positive. Is it okay to leave my answer like this? No. What's wrong with it? What do you have that you're not allowed to have in the denominator? You have a radical in the denominator. Exactly. So going back to what we did at the beginning of the year, what are you going to have to multiply the numerator and denominator by? You have to multiply the conjugate. Tangents, ladies and gentlemen, are always going to have the twists and turns in it. Tangents are going to have radicals in the bottom where you have to do conjugates, or it's going to be a complex fraction. So just get used to tangent being your trickiest one. Well, let's do the denominator first where it's the easiest one. Because remember, what happens when you multiply conjugates together? What happens with the outer and inners when you FOIL? They're going to do what? It becomes a whole number, but the outer and inners cancel. So you just have to worry about multiplying your first. 1 times 1 is a 1. Square root 3 times negative square root 3 gives me a negative square root 9, which is a minus 3. So now you do have to FOIL the numerators. Remember, first term, square root of 3 times 1 is a square root 3. Square root 3 times negative square root 3 is going to give me a minus 3. Negative 1 times positive 1 is a negative 1. And negative 1 times negative square root 3 is a positive square root 3. Combine like terms. Yes, Stu?
Are you not done yet?
No. So now the denominator is just going to become a negative 2. I can add square root of 3 plus square root of 3, which is a 2 square root 3. Negative 3 minus 1 is a negative 4. I'm not done yet, because what can you divide everything by? You can divide everything by a what? 2. Even bigger, you can divide something by not just a positive 2, but a what? Negative 2. So that's negative square root 3 plus 2. Okay?
Could you scroll back up?
Yep. Tangents are going to have more simplifying than the sines and the cosines. Okay? Yep. No. Okay, guys. Your homework, ladies and gentlemen, listen up. Shh. I'm going to hand out your quiz review right now, because remember, the sum and difference are not on the quiz on Monday. You have the quiz review as well as the 4.2 number 1 in your homework packet. Listen up. Shh. You can stop at question 6 on the 4.2 worksheet number 1, because we're not going to get a chance to get to problems like that. So we'll add the 7 through 11 to the homework for Monday night. But again, the homework tonight, you can stop at number 6 in the packet. Okay? Have a good weekend, guys. Everybody have a quiz review? All right.